For question number 9, we have the topic of permutation and combination, which is, you can see over here that how many different 4-digit number can be formed using the digit 2, 3, 5, 7, 8, and 9. So in any permutation and combination question, first of all, you need to identify which one to use, either permutation or combination. So in this question here, 9A1, to identify whether it's permutation or not, remember this, that the permutation, the arrangement matters. Okay, the arrangement matters. Like if you change one of the digit, either front or behind digit, does it change all the things? Yeah, it actually changed the number and it changed the sequence. So in this thing here, we can say that the arrangement does matter. Okay, so or you could understand like this: find how many 4-digit number or 4-digit password number, something like that. 4-digit password number. Of course, all of your phone, you must have a phone. Even if you don't have a phone, I believe you do know that a certain phone and most of the phone have a password. Okay, so how you want to create that password? Example, your password is 1234. What if your password changed to 123 4 123 then 5? So that means 4 and 5 behind at the last number, it does matter. So that's how you understand about permutation. So in my tips on permutation, that you already understand permutation arrangement matters and combination arrangement does not matters. And another thing here is that whenever you do a question, you put like a seats arrangement. Okay, you have here 4-digit number, you have 4 seats to be filled. Okay, imagine like that lah. Imagine like that. And then if each digit may be used only once in any number, so it does not have any condition. So straight away to identify this thing, how many digits that we have? 1, 2, 3, 4, 5, 6 means that we have 6 all of a number, and then to be put it into 4 sets. So 6p4, straight away 6p4. So that's how we do the calculation. So 6p4, how much is this one? Just press in the calculator 6 and then shift, multiply NPR and then multiply by 4. You're gonna get that the answer is 360. That's how we do for question number 9A1. Okay, let's continue to question number 2. How many of the number found in part 1 here are divisible by 5? Okay, alright. What does it mean by divisible by 5? When it is divisible by 5, behind or the last number must be the number that are divisible by 5. So in this number here, we have 1, 2, 3, 4. So last number here, either 2, 3, 5, 7, 8, and 9. Which one that can be divided by 5? So the one that can be divided by 5 is only 5 here. So you put 5 here. Okay, so once you put 5 there, then the calculation for 5 here is going to be 1p1. Why is it 1p1? Only one number to be selected to fill in one seat behind here. So the front 3 seats here, how it will be, the remaining here would be 5 numbers. Since that you already picked 5, we have a total of 6 number, 1, 2, 3, 4, 5, 6. You already choose 1, so you cross that one, you all have the remaining of 5. That's how we do it. Okay, and to be filled off, to be filled on to how many seats here? To be filled on to 3 seats. And then the calculation here, you need to multiply. So 5p3 multiplied by 1p1. Okay, of course you already understand that 1p1 is supposed to be 1, but just still that you understand how the calculation works. So 1 multiplied by 1p1 here, it's still 60. So that's how we do for question number 9A2. For question number 9A3 here, okay, we are still using the same number, which is, I'm going to list here 2, 3, 5, 7, 8, and 9. We have a total of here 6 number. Okay, so it's still in the same group of number. How many of the number found in part 1 are odd number and greater than 7,000? So here in this kind of question, we do understand that we have 2 conditions to follow here. Okay, we must follow these 2 conditions. If not, that means it could be our answer is wrong. So my tip is that we list all the possible situation and list all the possible condition for this kind of thing. Okay, even though it's maybe a bit long, but at least you do understand how it looks like. So first of all, let's list out the first situation, the first condition to be have here. So we have a total of 4 seats. Remember, 4 seats. They say it must be greater than 7,000. If they are greater than 7,000, the starting number cannot be less than 7. It needs to be more than and equal than 7. So I put over here is 7. Okay, I'm putting here is 7 because it must be greater than 7,000. And then behind number is odd. What are the odd number on the right side here? Odd number, it's either 3, 5, 7, and 9. Once you already pick 7 in front, then behind here it can be either 3. Okay, first of all, we list down it 3 first. Okay, this is the first situation. So to calculate here, in this situation here is going to be 1p1 because only one number to be selected on the first seat, and at the last number also the same thing, 1p1, also one number to be selected at the last seat here, and then remaining 2 here. Okay, remaining 2 here must be filled in 2 seats, but how many number available left? You already picked 3, you already picked 3, you already picked 7, so the remaining number is 4, so that's why it's 4p2 here. So the calculation here, you multiply 1p1 multiply by 4p2 multiply by 1p1, then you press in the calculator lah, 1p1, and then press equal, multiply by 4p2, and then multiply 1p1 is also going to be 12 lah. Alright, is that it? No, that's not it, because we need to list all the situation here. You can wait for the working first. You can list all the possible situation first, and then you do the working. Then the second situation, you start with, okay, you start with 7, and then behind here you end with 5. Okay, and behind with 5. Then the third one here, you start with 7, and then behind is going to be 9. It cannot be 7 and 7. Because the number can only be used once only. Okay, why is it be used once? Because in part 1 they say maybe used only once. Okay, that's how it is. So we are already done with the number starting at 7. What if the number that's starting with more than 7, which is what if it would be 8? If this would be 8 here, then behind it could be 3. So we list down all the thing here. Okay, then 8 and then 5. And then 6, it could be 8, and then 7. I'm going to do the continue here. 7th, on the 7th possible situation, we start at 8, and then behind is 9. Is that all? Yes, if we start at 8, that's all the possible situation. We can only have 4 situation that ends with odd number. And then continue again with starting with 9. Okay, if starting with 9, behind is 3. If starting with 9, behind with 5. Okay, and if starting with a 9, behind could be 7. Can they be 9 and 9? No, they cannot be. So in this situation here, we have all of this possible situation, and these are all the possible situations that you could see here. Even though the working is a bit long, and even though the working is a bit tedious, but in this kind of thing, it makes you clear what can you have and what can you not have. Alright, so we are done listing all the elements. Now we just need to calculate. In the second one is the same thing, which is 1p1 multiplied by 4p2 multiplied by 1p1. I will leave everything the same. 1p1 multiplied by 4p2 multiplied by 1p1. Same thing here, everything the same. I can say that everything the same here. Okay, you could see one by one, it's still the same thing. So I'm just putting here the same thing all over again from starting until the end. Okay, it's just the same thing. So every situation, the possible things here, we have 12. So the second situation, we also have 12. So this everything have 12. 12, 12, 12 possible here, 12 possible arrangement, and we have a total of 10 different situation, and each kind of situation have 12 possible arrangement. So what are the total possible arrangement here? You just 12 multiplied by 10 different situation here. So that you could have the total different arrangement is 120 different arrangement. That would be your answer. And that's how I do it. Every time of permutation and combination, we always do like this so that we clear what can we have and what we cannot have as to follow the condition. Okay? Next question here, let's continue, which is this one. It's also part of permutation and combination, but as you can see here, this is the number of combinations. Straight away we must use NCR. Okay, there's a combination of n items taken 3. This one is a bit confused. So what does it mean here? Just for straight away hint here is that number of combination of n items taken 3, it means NC3. NC3 here, straight away like that. So NC3 is equal to 92n. So how to find the constant n here? You need to expand this NC3 and NC3 here. So NC3 here, the way we want to expand this thing here, it would be just follow the formula. Which formula here? Go back to the top list here. The formula to be used is this one. Okay, n factorial divided by n minus r factorial multiplied by r factorial. That's the formula. That's the binomial things. Okay, so here we also have the binomial theorem. So to follow the binomial expansion here, it would be n factorial divided by n minus 3 factorial multiplied by 3 factorial equal to 92n. That's how it is. Okay, alright, so we have this on top factorial and we have this below factorial and 3 factorial. Expand what you know first. Okay, so of course the one that you know is 3 factorial. How do you know 3 factorial? Because you can press it in the calculator. Where is it in the calculator? Here you can see like this symbol 3 and then shift this symbol. Okay, like the exclamation mark here. Press equal, then you get 6. Okay, so I'm just continuing over here. N factorial equal to n minus 3 factorial multiplied by 6 equal to 92n. I can move this 6 here to the right side, it become multiply. And what can we do about n factorial divided by n minus 3 factorial? We can eliminate the n minus 3 factorial. How we can eliminate it? Remember, the formula of a factorial here, you can go back to your topic or you can go back to your notes and everything. Imagine if I have 5 factorial. Okay, 5 factorial means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So the next multiplication is reduced by 1. Same goes to n factorial here. N factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 until we don't know where it stops. What does it mean by until we don't know where it stops? Because we don't know the n number. So we don't know where it stops. So we just put it as the algebra or just a symbol that we don't know. So in this kind of thing, we can put at the end of it as the exclamation mark because we don't know where it will stop. We can continue, no problem. We can continue until the end. But just to put it the exclamation stop there because we know that it will be continued. So in these things here, what it will be, I'll continue over here. It would be n multiplied by n minus 1 multiplied by n minus 2 and multiplied by n minus 3 factorial divided by n minus 3 factorial equal to 92 multiplied by 6. 92 multiplied by 6 is equal to 552. 552n. Okay, so from here you can see that I can simplify n minus 3 factorial. I can cut this thing and simplify. So what I have here is going to be n minus 1, n minus 2 equal to 552n. So from here you can solve the equation. Alright, so to solve this equation here, I move this n to the right side. I move this n to the right side, it becomes divide, so it just left with n minus 1, n minus 2 equal to 552. So expand this thing, n square minus 2n minus n plus 2 equal to 552. So this thing you can solve it by quadratic. So n square minus 3n plus 2 minus 500 minus 550 equal to 0 because this 552 I move it to the left. So from here I can solve it by quadratic. Just put it in the calculator. The value of a here would be 1 and value of b equal to negative 3, value of c equal to negative 550. So you should get that the value of n here equal to 25 or negative 22. But can you have negative 22 as the number taken here? Cannot. You cannot have the negative number in a combinations. So the correct answer here, it would be n equal to 25. That's the correct answer. So that's how we do it, and then let's continue to the next question. By the way, if you don't understand this question, you can always rewind the video and you can put something in the comment below to ask further. Okay.